Okay, guys. Today we're going to look at what happens when we start adding and subtracting polynomials. Now, for the most part, we're going to keep them pretty simple, but we're going to start combining our multiplication rules, our exponent rules, and of course, our collecting like term rules. So, the most simplest example that we can give you is when we're doing nothing but adding, and you'll notice that there are no numbers in front of anything. So really what that means is there's an imaginary number 1 in front, but for the most part, we just ignore them and we don't care. So we look at this and notice my formatting. I know we were getting much better with formatting when school let out. Most of you are doing this, but it's one equal sign per line, and we're working down. So there's nothing in front, I can just drop the brackets. Nothing in front, just drop the brackets. And now we're looking for like terms. I have a 2p, I have a positive 4p, 6p, and then I have a -2, -7, combines for a -9. Take a second, try the second one. So again, 6x plus 3, oops. Come on. Oh, 6x plus 3. Now notice I have a plus minus 2x or a plus -2x. When I have two signs together, it ends up being a negative. Two different signs together. Here we have a positive -5. So once again, it stays a -5. We could expand it out, which we'll get into in the very next thing where we talk about distributive property, but it's just a lot easier to have one sign. Once we hit this point, we start with our distributive or our collecting like terms. 6x minus 2x, 4x, 3 minus 5 is -2. Now, in theory, you guys have been introduced to the distributive property before. You should have looked at it in grade 8, but since many of you have had a wild and willy grade 8, we're going to go over it again to be on the safe side. So wherever you see no sign, it means multiply. Okay, I know I've had this conversation with some of you, and a lot of you know it already. So it means that we're taking that 2 and times it by the 3x. We're taking that 2 and multiplying it by the 4. Now, you won't always have to write it out this way. I'm just doing it for teaching purposes. So we multiply by everything in the brackets. 2 times the 3x, 2 times the 4. Then we can finish our expansion because once again, no sign means that we're multiplying. So 2 times 3x, and then 2 times 4 is 8. These are not like terms, so we can't do anything further with it. It just stays 6x. Okay, so this is the in general. Try to get used to this, especially if you intend on staying at the academic level. We end up using this stuff more and more just to kind of give the mathematical explanation for what we're looking at. Yes, it's a pain. I find it difficult sometimes too, but there it is. Okay, give example 2 a try. So once again, we're doing the negative, include that negative with the 4, multiplied by both values, which gives you -20b, and then -4 times -2 is +8. Now, this one's a bit of a trick. And you know how I've been emphasizing this all semester long. Just because there's a negative sign in front of it doesn't mean that there is no number. And this is a big part where it comes up. Really, we have a -1 in front of everything in the brackets. So when we expand it, we're multiplying -1 times 3x squared. and we're doing -1 times 7. So we're still following the same method as we did in part A, but we have to make that connection that that negative sign means -1. Continuing on with that logic, here we have an x in front. So we're going to multiply x times x, which using our exponent rules, we now know is x squared. Probably had it memorized from before. And x times 2, 2x. On D part, we've got 3 times everything. It's a k, that's fine. 3 times 8. Yeah. 24. Now, these ones look a little trickier, and I guess they are a little trickier, but they're really no different than what we've been doing above. What we've been doing above has been looking at just half the equation, and we can expand that without any difficulties. So 21x minus 28, and then if we do the same thing, if we just ignore that first half and expand it, okay, duh. Then we can turn around and simplify. 21x plus 8x, -4, that negative stays with it, plus 2 is -2. Okay, likewise for that next one. So we pretend that that last one isn't there. And remember that negative sign is there, so we have to include that. -12x. And when we have an x times x squared, exponent laws, it's cubed. -2x times -8, positive 16x. Don't lose that x. Same thing, we look at that second one as though the first part isn't there. 2 times 5x, 2 times -1, and we're good. Now we look to see, can we clean up our mess? There's no other cubes out there. Makes the Avengers happy. There are, however, 2 x's when we put them together. We got 26 x's, and there's no other plain Jane numbers, so we just rewrite that out. Now, subtracting isn't, it feels different, but it really isn't different. Okay, now, this first rule doesn't always apply. Okay, the reason I say that, drop the brackets of the first polynomial, only works if the value is positive and a 1. If you look at C, where we have a -2, you can't do that. You have to expand out -2 times everything in the brackets. So really, I do have, when did that turn red? I do have this rule here, but it's only a guideline. We've got to look at what the value is in front. Neat, it's back, I wonder why that happened. Anyways, since it's a +1 in front, then everything just stays 3c plus 4. Now here we have that negative sign, so once again, we treat it like it's a -1, minus 2c plus 6. And man, that's terrible writing. I'll fix it up afterwards. I don't know if you noticed or not, I figured out how to change my handwriting into text. So in the PDF, anything that I've handwritten, I've actually gone back and changed it into text. So if you can't read it off this, have a look at the PDF. 3c minus 2c is just c. 4 plus 6 is plus 10. How did I know it was a plus? Because 4 plus 6 is a positive 10. My favorite refrain, A plus sign is a positive sign. A positive sign is a plus sign. Same thing here. We have a positive 1, 7x plus 3. We have a minus 4. So we got to do that negative 4 times 2, negative 8x, and negative 4 times 8, negative 32. Let's collect our like terms. 7x minus 8x is negative x, plus 32 minus 32. What is that? Negative 29. If you need a calculator for the stuff, that's fine. Yeah. And the last two, slightly more complicated. The last one in particular is more complicated. Give them a shot. Remember your exponent rules when you're expanding. X squared minus 8x squared. There's only one x. Lonely old x. There's only one 6. Lonely old 6. Oh, that's a 21. Some reason I did that. All right, I'll fix that real quick. The advantage, oh, I forgot that there anyways. So, 21, where do we go? 21x and minus 6. Yeah, as I've proven time and time again, teachers make mistakes. My first video actually had to re-record about 8 times because people kept making mistakes, me being the person. There's different ways that you can approach this one, and none of them is wrong. They're all correct. I guess I should be positive about that. As long as you get the final answer correct, I'll probably be happy. So there's nothing you can do inside the first set of brackets, the 5x minus 2, so the brackets are done. So we're going to expand that out. We haven't done anything with the 6 yet, so it just stays a 6. And collect like terms within the brackets. 3 minus 2 is 1. Now we can expand again. And we're finished. Okay. There is a second way you could do that that would be correct. And you're welcome to do it that way if you want. Doesn't matter to me. Again, as long as it's mathematically correct and you get the right answer at the end, you're good. So we got homework at the bottom here. We got homework at the bottom here. Maybe I shouldn't cover up the homework at the bottom. Enjoy.